Hey all, welcome back to my channel and I hope you are all doing great. Today we are going to solve this problem, sort colors. Given an array nums with an objects colored red, white, blue, sort them in place so that objects of the same color are adjacent with the colors in the order like red followed by white followed by blue. So how they are representing is red with 0, white with 1, blue with 2. Okay, and you are not supposed to use any inbuilt functions to sort this one. So how our input looking like is 2 0 2 1 1 0. Now let's try to understand how we can solve this particular problem. The Navi approach or is the base approach, someone can think of using any data structures like maybe tree map in this case. So what I'm going to do here is I'm going to use tree map to count the number of occurrences of each element and store their occurrences also. Okay, like 0 comma 2 where 0 occur 2 times, key value pair, as you know map stores data in the key map pair. Then 1 comma 2 1 occur 2 times, then 2 comma 2 2 occur 2 times. Once it's done, then I iterate through all the tree map entries, and if this is 2, I mean I take this value into the consideration, and how many times this occurred, that many times I insert the key into the nums. So initially nums. Okay, something like this. Let's assume. So 0 occur 2 times, then I have insert two zeros. 1 occur 2 times, then 1 2 times. Then 2 occur 2 times, then 2 2 times. Like this. Okay. How much time and space complexity is going to take? So it takes big of n log n. Basically, tree map sorting this, so it takes big of n time log n n log n time complexity, I mean to say. So space complexity also big of n. This is not good, so interviewer is not going to happy with this. So is there any other approaches through which through that like we can reduce our time complexity? Yes, we do have, by taking no extra space. When I say that, no extra space to store the input or output apart from constants. Okay, let me write that apart from constants. Great. So basically how this is going to happen is, so we are going to take two variables, namely ones and then twos. So if our input is of this 2 2 1 1 0, what I do is in one pass I count the number of ones. Okay, number of ones are 2, number of twos are 2, by placing number of zeros at the left side of the array. In the sense, so 2 first, let's say we are starting with the first index. So what is the value of this? 2. I increment 2's by 1. Okay, so initially they start with 0, right? Then it's 1. So this is 0. Then it's 0. When it's 0, then I put this here. Okay, I don't need to worry about previous 2 because I already have a count. Then I come here, again 2. Then 2, counter of 2 incremented. Then I come here, again 1, incremented. 1, incremented. 0. Then I put here in this position, at index position. So once I done visiting all the elements in this one pass, I am going to have left side is sorted with zeros and right side it's going to have something unsorted. Okay, so now I know the left side is sorted. All I need to do is I need to iterate through the count of ones and twos, and then I fill. Example, this 2 times, right? I iterate 2 times, then I fill ones here like 0 0 1 1. Then twos 2 times occur, right? Then I insert 2 2. That's it. So basically the agenda here is we count the ones and twos while placing zeros to the left side of the array, and we iterate through this ones and twos count separately in another pass, then we push them into this array. This approach you take big of n for initial one, and again big of n, the actually the sum of zeros and ones plus twos are equal to big of n. So it's big of 2n, the time complexity, and space complexity is big of 1 only because you are not going to take any extra space apart from this constants of ones and twos. This is bit better, and I can say it's a not a bad approach, it's a better approach. Okay, but it's not an optimal approach. Do we have any good approach through that we can solve this in big of n time complexity? Yes, we do have. That is nothing but Dutch national flag. Cool. So let me quickly show you what Dutch national flag is. So you can see here, I just have something. So the Dutch national flag algorithm is a sorting algorithm designed to arrange an array of elements containing three distinct values in a specific order. So either it can be 0, 1, 2 or else 2, 1, 0. Okay. It was developed by Edsger Dijkstraat, a Dutch scientist, computer scientist, and is often used to sort an array of zeros, ones. And so for this problem, Dutch national flag is a go-to algorithm for an optimal solution. So basically, this is also known as three-way partitioning. Okay. Now, what this says is it basically uses three variables: the low, try to understand carefully, mid, and then high. So it has certain rules. What those rules are is from zeroth index to low minus one. Okay. This is we call extreme left. Extreme left is sorted with zeros. From low till mid minus one, okay, it's sorted with ones. From I plus 1 till n minus 1, where n is the number of elements, this we call as a extreme right. Okay, it's sorted with twos. Cool. Now you can ask me, "Hey, Shiva, where is that portion like where from mid plus 1 equal to high? Where is that, man?" So actually here it mid minus 1, so it's mid only, from mid to high. You can ask me, right? So this is the portion where your input is either having ones or twos and zero. This is unsorted. So basically we are going to focus on this portion, okay, in order to sort this array so that your input is going to be sorted as expected. Okay. Now you understood these three rules of Dutch national flag algorithm. All right. Now we'll dry run this one with the help of our input. Okay. What is our input? 202 and then 110. Okay. Basically, what Dutch national flag says is two rules in terms of solving. So if given number equal to 0, then swap it low with mid. Okay, as I said, what low, what's mid. Okay, then as soon as you're done, increment your low and increment your mid. This is when 0. The second is if num equal to 1, you no need to do anything, rather just increment mid. Why? Because you are swapping left side, you are going to swap right side. So both left and right sorted, I mean swapped or else sorted with the zeros and twos. That means the mid portion is going to hold only 1. Okay, that's the reason we don't do anything here. So the third one is num equal to 2. If this is the case, then swap your mid with high. Okay, that's it. We generally do these three checks while writing our code in order to derive our solution. Now we'll go to this and then we'll see. Okay, before that, let me quickly show you how the code looks like before we even submit. So int low, int mid, high, swap lowing with a mid and mid with a high. So that is what I said, right? So okay, by the way, I just forget to inform high should be decremented because you're swapping high. So now let's dry run this one. As I said, what is the value we are going from left to right is to which category it falls under this. So initially, by the way, I forget to say initially low points to this, mid points to this, high points to this, and we are going to iterate while mid less than or equal to high. This is our base condition to exit from the loop. So is mid equal less than or equal to high? Yes, mid is 0th, high is at 5th index. Cool. Then what is the value of mid? 2. What I need to do? Swap mid with a high and then increment a high. So if I swap this, how my input looks like? 0, right? 0, 2, 1, 1, and then 2. Cool. Then I need to decrement my high. My high will be here. Cool. Then my low mid remains at the same location. Then I check my low here and then my mid here and then my high here, right? I check is it 0? Yes. What I need to do? Swap low with high. If you swap low with high, the value remains the same, but you need to increment low and mid. So after this step, what is going to happen? 0 0 2 1 1 2. So your mid is going to be at this location mid, your high is going to be sorry, low is going to be this location, and high is at this location, right? You are done with that. Then you are going to be start start looking at this. Is it zero? Yes. So if it is zero, then you swap low with high, and then you increment low, you increment mid. Okay, then mid is going to be this, low is going to be this. So 0, 0, 2, 1, 1, 2. Cool. So by this time, where your mid, high, low are, your low is here, your mid is here, your high is here. Cool. Is it 0? No. Is it 1? No. Is it 2? Yes. What you need to do? Swap this mid and high. So what going to happen? 0, 0, 1, 1, 2, 2. Right? Then you need to decrement your high, isn't it? If you decrement your high, so your low is going to be here only, your mid is going to be here only, your high will come to this location. Cool. Then you check what is nums of mid. It's 1. Then you simply increment your mid. You check what is nums of mid. 1. Simply you increment your mid. Then you check, and here it fails, right? Mid less than or equal to high. No, mid is ahead of your high. Your high is this and your mid is this. So this condition fails, and by the time this condition fails, you can see our input is sorted. That's all. Basically, what I can say, our I mean to say, our input got sorted. Okay. What is the time space complexity? The time complexity is big of n, the space complexity is big of 1. This is much far better than what we did as part of two approaches, right? So if you didn't understood this Dutch national flag, okay, please watch this portion again and again. I'm posting some timestamp on this again and again. You watch. If you still don't understand, you just comment like I didn't understand. Then I can make another video only specific on this Dutch national flag very soon. Okay. I hope you learned something new today. But before that, let's submit our code and mark our tracker. So here is I am. So I'm going to take this copy complete code. Okay, right from, okay, let me take complete class. Let me replace. Cool. This is just to save some time because I already wrote, right? So, great, it got submitted. It took 0 milliseconds. That's great. So I quickly show you the other approaches where I spoke about tree map and the counter, right? Let me try to find whether I have those. I think so. Yeah, this is arrays.sort. This is what they are asking us to not go with. And then maybe tree map. Yeah, cool. So this is our tree map. As I said, like this is how code looks like. So I iterate through all the elements initially, put it, and then I going to take the value that is like each 0 or 1 or 2, how many times it occurred, and then I'm going to run a loop for that, and then I'm going to insert those many times that number into the index, where index starting from 0. So this is one, and one more thing is going to be like a counter. Cool. Here you can see ones and twos, and the index is 0. So I'm iterating through only one time. So here, so by the time this runs, so my left portion is already sorted, and I'm incrementing ones and twos. And you see here, if it is 0, I'm inserting into the array directly. If it is 1 or 2, I'm incrementing the counters. And second loop, it's going from 0 to 1s. How many times 1s occur, those many times I'm inserting 1, and then 2s, and then I'm going to insert 2. Okay, this is a bit lengthy video. I hope you learned something new today, and don't forget to mark in our tracker sort arrays, sort colors. And great, it's a medium level problem, and we solved 6 out of 75. More to go. Till the next video, bye bye. Take care.